Real numbers are all numbers corresponding to points on the number line. And we're going to look at specific types of numbers. When we're small, we're first introduced to natural numbers, which begin with 1, 2, 3, and continue infinitely. Whole numbers, as we get a little more sophisticated, we have a symbol that represents nothing. Whole numbers, the only difference is that between that and natural numbers is that it starts with 0, 1, 2, 3, and continues on infinitely. Integers are numbers that are signed numbers, and they're opposite. They decrease infinitely and increase infinitely. Next, as we get a little more sophisticated, we have another set of numbers which incorporates these first three sets, known as rational numbers. Rational numbers is the set of all numbers of the form P over Q, in other words, expressed as a fraction, where P and Q are integers and Q is not equal to 0. We can take these, and as long as the numbers terminate or repeat, when we convert the fraction or rational number into a decimal, it falls into this category or set of numbers. For example, 1/2 is a rational number. If we have its decimal equivalency, which is found by taking the numerator divided by the denominator, we end up with 0.5, which terminates and stops. If we have the rational number 1/3 and we convert it into its decimal by taking the numerator divided by the denominator, 1 divided by 3, we end up with 0.333 repeating, and so it also classifies as a rational number. All integers, whole numbers, and natural numbers are rational numbers. If we have -5, we can express it as a rational number by putting a denominator of 1, and when we do the division, we're right back at -5, terminating. A special class of numbers are called irrational numbers, which is a set of numbers when written in decimal form neither terminate, like the examples I have here, nor repeat. Some examples are, the classic is pi, which is the symbol here, and is equal to 22/7. Now, on first glance, 22/7 looks like a rational number. But if you do the division, 22 divided by 7, this never terminates or sets up a pattern. Do the division on your calculator, it will fill the display, but it continues infinitely without repeating, thus making it an irrational number. Other examples are square root of 2 and square root of 3. These are not perfect squares, and the decimal equivalency does not repeat itself or terminate. The square root of 3 is approximately 1.732, but again, strongly emphasize the word approximate because this value does not terminate to a final value. Again, rational numbers, which natural, whole, and integer are part of, along with irrational, combine to give us the real number set, which is every number that we can represent on the number line.